In this video, we are starting our journey into SQL, the language that makes databases work. Whether you're building a small project or managing large-scale data, SQL is a must-know skill for organizing and handling information efficiently. Before we learn how to create a database, let's quickly go over some basic rules for naming database objects in SQL. First, always use meaningful names that clearly describe the data inside, like students, instead of something vague like TBL1. The name must begin with a letter and can include letters, numbers, or underscores, but spaces are not allowed. If you need multiple words, use an underscore instead. For example, order underscore details. Also, avoid using SQL keywords as they can cause errors. Keeping these simple rules in mind will make your database well structured and easy to understand. Since SQL is all about working with databases, the first thing we need is of course a database. So to create a database, we use the create database command, followed by whatever you want the name of the database to be. And at last, don't forget to end the statement with a semicolon. In SQL, the semicolon plays an important role. It marks the end of a statement. While some database systems might not strictly require it, it's a good habit to always use it. This becomes especially important when writing multiple queries in a row, as the semicolon helps the database know where one command ends and the next begins. So once the database has been created, it is permanently saved on your system or server. To check the list of all the available databases, you can use the show databases command. This will list down all the databases that you have already created. Now that we have the database created and ready to start working, we now have to specify the database that we want to work in. For that, we have the use statement. We just write use followed by the name of the database we want to work in. Before we start creating the tables, it is essential for us to know the different types of data in SQL. Firstly, we have int, which is used to store whole numbers like 10, 200, or -50. It is perfect for storing data such as age, employee IDs, or quantities, where decimal values are not needed. Next, we have float, which allows us to store decimal numbers, making it ideal for data such as price, percentage, or weight. If precision is crucial, especially for financial data, decimal might be a better option, but for now, just remember that float is used for numbers with decimal points. Moving on to text data, we have char and varchar. Char is used for fixed length text, meaning if you define char of length 5, it will always store 5 characters, even if the actual text is shorter. This makes it useful for things like country codes or fixed size IDs. On the other hand, varchar is a variable length string, meaning it only takes up as much space as needed, making it perfect for names, email addresses, and descriptions where the length can vary. Finally, for handling dates, we have date, which stores values in the year, month, date format, making it perfect for things like date of birth and order dates. There are many more data types in SQL, but once you understand these fundamental ones, you'll find it much easier to learn the rest as you progress. Now that we know the data types, let's move on to actually creating tables. So to create a table in SQL, we use the create table statement, followed by the table name and a set of columns inside parentheses. Each column is defined with a name, a data type, and optional constraints like primary key to uniquely identify each row. For example, if we want to create a table for employees, we can write the following SQL statement. This creates a table called employees with 4 columns: ID, name, age, and date of birth. The varchar of length 50 means that the name column can store text with a maximum length of 50 characters. Once the table is created, it is stored in the database, and we can start adding data into it. If we ever need to see all the tables in our database, we can use the show tables command. Creating tables is the foundation of SQL, and once you understand this, you're well on your way to building and managing databases. Once our table is created, the next step is to insert data into it. In SQL, we use the insert into statement to add new records. Let's start by inserting a single row into our employees table. Here, we specify the table name, followed by the column names in parentheses, and then use the values keyword to provide the actual data in the same order. This adds one employee with the ID 1 and the name Atto, age of 25, and a date of birth 1999-06-15. But what if we want to add multiple employees at once? Instead of writing separate insert statements, we can insert multiple rows in a single command like this. This adds 4 more employees in a single query, making it more efficient. Notice how each row is enclosed in parentheses and separated by commas. Once we execute this command, all these employees will be stored in the table. Now that we have data in our table, let's learn how to retrieve it using SQL queries. In SQL, the select statement is used to fetch records from a table. The most basic way to retrieve all the records from our employees table is by using select star from employees. The star symbol means select all columns. So this query will return every row and column from the table. However, in real-world scenarios, we often don't need all the data at once. To filter records based on specific conditions, we use the where clause. For example, if we want to get employees who are older than 25, we write select star from employees where age greater than 25. Similarly, if we need to find an employee named Kiwi, we use select star from employees where name equal to Kiwi. The where clause is powerful for retrieving relevant data efficiently. In some cases, we may want to sort our results. The order by clause helps us arrange data in either ascending or descending order. To display employees sorted by age in ascending order, we use select star from employees order by age ASC, where ASC stands for ascending. If we want to sort them by name in descending order, we write select star from employees order by name DESC, where DESC stands for descending. Sorting makes it easier to analyze and present data in an organized manner. When dealing with large databases, fetching all records may not be ideal. The limit clause allows us to restrict the number of rows returned. For instance, if we only want to retrieve the top 3 employees, we write select star from employees limit 3. If we need to get the 2 oldest employees, we can use select star from employees order by age DESC limit 2. Now that we have learned how to retrieve and filter data from a table, let's explore aggregate functions in SQL. Aggregate functions allow us to perform calculations on multiple rows at once, making it easier to analyze data. These functions include count, sum, average, max, and mean. One of the most commonly used aggregate functions is count, which helps us determine the number of rows in a table. For example, if we want to count the total number of employees, we can use the count function. Similarly, we can count only those employees who meet a certain condition by applying a where clause. Another important function is sum, which helps us to add up numeric values. For instance, if we need to find the total sum of all the employees' ages, we can use the sum function. In the same way, if we want to calculate the average age of employees, the average function comes in handy, allowing us to find the mean value of a specific column. Sometimes we may need to find the oldest or youngest employee in the company. The max function returns the highest value in a column, while the mean function returns the lowest value. These functions are particularly useful for identifying the highest and lowest values in numerical data, such as the maximum and minimum ages of employees. While aggregate functions are useful on their own, they become even more powerful when combined with the group by clause. Group by allows us to categorize data into groups, then apply aggregate functions to each group. For example, if we want to count how many employees belong to each age group, we can group the employees by age and use the count function. By mastering these aggregate functions, you quickly analyze large data sets and extract meaningful insights. Now that we have covered the fundamentals of SQL, from creating databases and tables to inserting and retrieving data efficiently, it's time to put this knowledge into practice. In the upcoming video, we will go through some sample SQL questions to reinforce key concepts and enhance problem-solving skills.